with my slides. Okay, so let's get started. I will be speaking about product and project management. And so my background, I've been working in AI for more than 20 years. And I founded the company Data Monsters back in 2006. So we have more than 15 years in AI consulting and professional services. We have several research labs in United States and Russia. And yeah, so I have a lot of stories to tell about what AI is and what it's not, and how to deal with clients. Yeah, we are doing consulting work, but we work a lot with internal teams, and I see it from inside how AI projects are starting. And there are projects in big companies like Google, Facebook, Yandex, and others. And there are also companies who are just starting, and I think that will be focus of my discussion. We will be talking about how to establish understanding between business sponsors and data scientists. And I think, well, that is one of the most challenging parts in our business, is to do that and kind of to go through the project and deliver results. Okay, so this is how a typical research project may look like. It starts with enthusiasm, and well, you may probably know this curve, inspired by Paul Graham's startup curve. And it's pretty much the same. Startup is also a research project. You are doing your customer discovery first, and then you find kind of way to build a product. Then you get your first clients. You experiment. You go through ups and downs, through failures, and finally you find your holy grail. But unfortunately, well, it's only like really small probability that you succeed. And a lot of projects they are canceled before your holy grail quest is over. Yeah, so Quest, I think Quest is the right name for a research project, and it shows the difference between traditional project management, like projects, and project is something which is quite predictable. In delivery business, you have something that you need to deliver, and well, it's pretty much predictable. Some failures may occur down the road, but well, you expect, like with this delivery shipment, you expect it to be solved within several days. For example, if you have a bug in your code that you deliver, your clients would expect you to fix this bug and come back next week. But in discovery projects, it's completely different. You don't know what you'll find, and you don't know how long it's going to take. And you basically, your AI inaccuracy is not a bug. You cannot fix it over a weekend. It may take like several years of fundamental research before you find a solution. So this is really important to kind of to stress that delivery and discovery are different processes. And if you are expected to be a delivery manager, no, you are not. You are a discovery manager, and discovery is a separate kind of type of business, and it's much more closer to venture business than to traditional software business. So you need to work with risks and uncertainty. So this is the main thing. You don't know what you'll find. And if you if you want a metaphor, it's a labyrinth. So you have a research project is a labyrinth. You start somewhere and you want to get through the labyrinth, but you have only small pieces of the map. You don't know the whole map. You start exploring. You may take the wrong path, and you will spend your time, resources of your team, and you find yourself in a dead end. Well, and you need to kind of turn back and start over. So this is really painful because, well, you have limited resources, you have limited time, and well, everyone is expected, like when a sponsor looks at the labyrinth from bird eye view, it looks like not a long walk at all. If you just measure distance, that's a straight line distance. But in fact, you will need to test different assumptions and go through blind alleys and turn back. And that is crazy, because your sponsor will say, what, you want more time, you need like more money? So that was supposed to be a short walk, so why are you still messing around? So this is what will happen, because, well, it will take like 3 times 5 times more than expected. So it's your job, so be prepared and manage risks. So that's why we created that Quest method, or Quest framework, which is basically a LeanDS framework. The ideas are, well, are built together in the community, in the Lean data science community. So we at Data Monsters, we are monsters, so we are crazy a little bit. So we created that framework, putting together all the best practices and make it fun and valuable. So first you need to understand your mission. Then you do some, you need to create a map to map your uncertainties. Then you do exploration rates to loot some findings and pieces of your solution. Then you craft a solution out of those pieces, and you test that solution, and you try and kind of you iterate it, and you go through this labyrinth, and you meet some dragons, you fight dragons, well, and finally you find your way to the boss, and with your hard-won treasure. Okay, so let's get started. And every quest starts with a quest giver with a good question. So this guy has money, and he wants you to solve a research problem. Okay, so research is an expensive thing, of course, and you need to have that well-heeled and motivated quest giver. So he or she should sponsor this research to solve the really big problem. And so you as a manager, you want to establish that after accepting this quest, you want to kind of to find your data science team and establish that communication and basically help them convert the business problem into a data science problem. And well, you may be familiar with the jobs to be done approach when, well, you formulate the product functions in jobs to be done concept. So here we have the same thing. In fact, AI is a decision-making machine, and your data scientists are building that decision-making machine, and DTBM is something that they need to kind of to build. It could be one-time calculation, for example, if it's a BI something, an executive, they build, they create executive slides, or that could be real-time processing. Then you need to make these decisions in real time. But in fact, yeah, so AI is a decision-making machine, and decision to be made is something that, so there is some theory behind that, but we will just remember that. And of course, as a manager, you have that classical triangle, quality, budget, time. And in AI, it looks like this. Basically, your quest giver is concerned about ROI. He's sponsoring the project, and he wants to have some interesting results that are available for his or her business. Well, scientists are going to take care about decision-making machine accuracy, and they would like to have a Kaggle structured problem. They want the labeled data, they want the metric. So this is something they want. Yeah, they're comfortable with that. And and you as a manager, you want
Artemy, sorry. Seems like your slides are stuck.
Oh my God.
We see the labyrinth slide.
Sorry for that. Sorry for that. It looks like Zoom is a trash. Sorry for that.
It's the best trash on the market.
Yeah. So I need to optimize it for video clip. So I think that will. Oh, this is so bad. Sorry for that, guys. Again, so your labyrinth, you need to go through the labyrinth, and this is Quest framework with a kind of mission, map, research rate, exploration rates, crafting your solution, fighting dragons, and finding your hard-won treasure. Okay, so it starts with a quest giver and his or her business problem that you want to solve. And yeah, so I was speaking about a decision to be made approach when you have to translate your business problem into a data science problem and to do it within budget, time, and quality. So your quest giver is concerned about the schedule and the budget, ROI, and your scientists are going to take care about your decision-making machine accuracy, and they want it to be a Kaggle structured problem, in fact. So we are at the and you remember that there is a labyrinth, like the railroad is going to be much longer than you planned. So you need to keep eye on emerging risks, and one of the main risks is to do something that is not valuable to the sponsor. In fact, yeah. So probably the best thing you may do on the week one of the project is to organize what's called mission understanding workshop. We saw a lot of canvases during the last 5 days. So this is another canvas that we use. And so what we do, we bring business people and data scientists together in one room and spend at least 2 hours to discuss the problem. Because shared understanding achieved early will save you a lot of time down the road. So first we speak about money. Money is the king of all metrics. And yeah, you want everything to be measured with some dollarized or some other currency value. And yeah, that will be really great to understand how our data science metrics affect dollars. So don't hesitate to talk about this. Yeah, you need to understand ideas. Probably this company, if you work as a contractor, you may need to understand what this company was trying before inviting you to join them on this project. But anyways, business people or internal clients have the same problem when speaking to data science teams inside one company. They may believe in some methods or they may have the ideas. So facilitate this discussion to discuss what ideas they have and what they tried, what other competitors are doing, and what other research papers are published, and so on. So strategy is also important because your quest is a part of someone's larger game. And if sponsor wants to sponsor that research, probably they have a bigger strategy and milestones in mind. For example, if you build something for manufacturing, you may have a research project for one single factory, and you calculate your metrics and you observe that, well, you will be probably saving only $10,000 a month or a year. That doesn't look much, and that doesn't look paying back for the investment, for research investment. But if you learn that this company has or this business has let's say 100 production lines in different countries, that makes it reasonable because you understand the scalability of your task. You understand that there is like some strategic goals there, and well, it's really important to understand these strategic goals of the sponsor when you face some blocking obstacles, because you will face these obstacles, of course, and you want to be flexible enough to pivot and to find workaround. If you know the strategy and you have support, you will do that. If you are trying it blind, you will find yourself in a dead end of the labyrinth. Well, of course, you discuss skills presented in the room, and probably you need some other people, like some advisors. So we usually invite knowledgeable people from university labs to join our projects, and that is really helpful, because these guys already did all sorts of mistakes. As Niels Bohr said, expert is someone who did all sorts of mistakes in the narrow field. So this is, yeah, so they already know some pieces of the labyrinth, they know the map, and they will save you a lot of time. So don't hesitate to work with researchers, even from your competitors, because, well, if they do not disclose any like trade secrets, but yeah, there must be some communication between companies to find workable solutions. And yeah, so you have inputs and outputs. Well, already there was like a really deep discussion around these. The previous talk was also about how to what questions should be asked before the project starts. I would also say about nuances, and well, nuances are really like hidden dragons that you will face later, because sometimes you have a good project, but well, there are some restrictions, unspoken expectations that you will kind of find out later, and you don't want any surprises in your project. So ask about that as well. Okay, so you need to build some sort of a solution for that problem, and yeah, so I think you all scientists, you all know all that, but just to kind of to this is one picture image of any AI. You have a black box with inputs and outputs. There are some events generating data. They get into the black box. You have a pipeline, typically recognition, forecasting, and making choices. And well, there are names that scientists know, like classification, prediction, ranking, reinforcement learning for feedback loop from actions, and clustering as an unsupervised method to make your classification faster, to prepare training sets faster. And you have human in the loop. So these are scientists, and basically they let's make it simple. It's all about accuracy or some other performance metric, but I will name it accuracy to make it simple. So you want your algorithms and your decision-making machine to be accurate. So these scientists, they spend their time to train the system, to fix inaccuracies, to prepare data. Yeah, so this is their job. And well, after you design that, you have that in mind, you need to kind of get back to your sponsor, say, okay, that will cost you that much, right? So they're expecting your budget, and there is like a bad news for you, because, well, there is no budget. There is no specific budget for an AI project. For other projects, it may be kind of like $1 million scale, and yeah, so probably if you build in a website, it's not gonna cost you $1 billion. Yeah, it's gonna cost you probably like several, like 10 or 100,000, but it's not gonna cost $1 billion check. But in AI, that may happen. For example, if we're speaking about self-driving cars, well, $16 billion was spent, and why? Because you need the 99.999 accuracy. I mean, you need your car to be safe. It's 1% inaccuracy is not affordable, because, well, you will have an accident every 100 times you have a ride. Yeah, that is not what you want. You want to have really high accuracy, and the accuracy is really expensive when it gets to 100%. So if you are, if someone asks you how much is your AI, there is no right answer. There is no fixed price for AI. And again, that is not just budget, that is like duration of your research, right? It could be 10 weeks, it could be 10 years, right? And yeah, so this is, and people ask, why is that? And there is an answer which is not yet discussed. Unfortunately, I don't know why, but well, to me as a scientist is pretty clear, because you have long tails, and long tails, well, I saw really small number of papers. Well, you may know Nassim Taleb, Black Swan book, and well, it's about long tails and statistics of long tail distributions. And for example, this is a frequency distribution of retail bank requests. And well, it looks like, okay, we have frequent requests and we have really kind of infrequent requests. What's wrong with that? Okay, let's look at the next picture, and which is ImageNet categories by frequency. Pretty much the same thing, right? It looks like, okay, we have most frequent objects in the world, less frequent. So the most frequent are like trees, different types of fish, people. Yeah, it looks like, okay, what's that's okay. Let's kind of probably train our model on these like first 100 classes and make it accurate. And we will probably cover all the distribution with this model. No, the answer is no, because well, if we get that ImageNet distribution, that the tail will be 56% of the whole population. Yeah, the tail that we saw is only 44%, and the tail, the long tail, is 6% of infrequent and low frequency objects. And you may know that from like Google advertising, natural language processing, and so on. So there are many use cases where you have long tails. And what it means from a budget perspective, it means that you will spend a lot of time to get closer and closer to 100% accuracy. So this is I think you know this graph already. This is a state-of-the-art ImageNet classification algorithms, top one accuracy. So you may see a lot of gray circles, and these are published articles during the last years. And you may see how many people and research groups are working, and they cannot beat that state of the art. They publish the article saying, okay, we have only 82% accuracy, but probably this is the right path in the labyrinth. Probably this way that they found will lead them to a breakthrough in 2 years or 3 years. So this is why even 90% accuracy could be a really big and expensive problem here. And the same thing for other projects. And again, banks would like to have 95% accuracy just because they are taught in a principle of Lean Six Sigma, when, well, you may allow only less than 1% defect, like defect rate, or less than 1% failures. In data science, 10% is a good result. 10% failure rate is a good result already. And for example, in natural language processing, in speech to text problems, you may have like 25% word error rate, which is cool. Especially if you have noise and well, really like specific language models, language domains. Yeah, sometimes 70% is good. And this is why, well, you need to talk to your sponsors and explain that, yeah, we need to find an intersection between business value and accuracy. Don't expect 95% accuracy. Just because it's a like fundamental problem, research problem here. Okay, so this is again, if you plan the project, it's typical you're not going to dig into one specific problem. And typically, so what we see that companies are trying to have what's called portfolio of AI initiatives. And they are kind of like in venture business, they want to have several potential like proof of concept projects, converting to pilots, and then scaling. So the same way. And in fact, there are like there's a conflict for you as a manager on each phase, because you want to show great results, but you would not overfit your model, and you would kind of give results which is quite fine to get to the next step. If you overpromise, you'll have a really hard time on the next phase, because well, it's getting harder and harder. And so don't overpromise. And at the same time, you need to test risky assumptions, and you need to build something amazing and great looking to engage with your sponsors and get to the next step. And this is a contradiction, because well, too many pilots are designed to succeed rather than fail. Because well, everybody's in corporate environment, everybody's happy about success and they're not happy about failures. But if there is like, research is a try and failure approach, you need to fail as well. You need to find what's not working during your pilot, and you need to be, you not need to be blamed, you need to kind of to be praised for these failures. This is crazy, nobody understands that, but this is how well it works. You need to fail to find a solution. Okay, and yeah, so let's move forward. And as I said, the money is the best metric. And unfortunately, business people are a little bit hesitant about speaking with data science about money. There could be some trade secrets there, and they don't want to, for example, to disclose the right cost per operation. While data scientists, they also don't know about like budget they need to deliver. And that's why we came up with a special currency, which is a fictional currency called Escudo. Escudo is a fictional currency for project estimations that is tolerant to inaccuracy. So one escudo is 1 week of work around that, and it could be $1,000 to $10,000 of business value. So you want to have some currency, some unit to measure, but you need to understand that both from business side, it's not accurate, and from your data science team, it's not accurate. So this is how we measure when someone comes and say, I need to build an AI product. We need like proof of concept. How much does it cost? There is no right answer, but with Escudo there is. We just take this table and say, okay, you want, let's say you need you need the proof of concept. You have tabular data. It comes from third-party sources, so we need to probably do some integrations with some unknown sources. There are like there are only two classes. For example, it's like true or false algorithm. This is easier. You need to run it in real time, which is not that easy. And 60% accuracy is fine to start. And well, it's coming from innovation budget. So there are some people who are interested in this. Unfortunately, with innovation budget, there could be a big problem to find internal client who wants that. But innovation people, they really want to build some innovative something. So you have at least some support. So, okay, it's 1 plus 2 plus 1 plus 4 plus 1 plus 2, 11 escudo. It's about 11 escudo and 11 man week of work. And when you measure business value, so we already saw some presentations last days about how to estimate business value. And yeah, so in fact, you have what's called total addressable business value. Even if you have 100% accurate algorithm, you're not going to make billions of that. Probably you have, if you eliminate all defects in your production, or if you if your chatbot responds super accurately, is it like 1 billion of value? Probably not. Probably there is upper limit, and there is a lower limit. For example, some level, some accuracy level when there is no reason, there is no economic sense to invest in this AI solution. So when you kind of have these 2 points, you may draw a curve, a line, or some saturating curve, and that would be probably in a Scudo evaluation. That would be probably something that is relevant. And in fact, what do you have? You have several like ideas, and of course, so these are some potential real numbers with a pilot cost. It could be like 30 Scudo, and estimated value of 500 Scudo during the next 3 years. So that makes at least some the ruler to measure your like business cost and value. Okay, and of course, to finish with that, you have some open questions, and you have of course, you have your mission canvas. It's okay to have unanswered pieces, and these are uncertainties that you will work with on the next step. Okay, so in fact, when you get to the next level, you have uncertainties. You discuss the problem, you pretty much understand you have some idea of a budget, you understand what you need, you have some architecture in mind, some really preliminary architecture with 3 blocks, recognize, predict, and make a choice. And well, you need to organize all that. And so what do? You need to discover and to talk to people and to convert uncertainties into working items. In fact, uncertainty in research project, as uncertainty is your working item. Ashat has discussed this problem and saying, okay, your ticket is a hypothesis. I would say no, your ticket, especially when it's early stage, your ticket is uncertainty, and you need to kind of get these uncertainties and move it through your funnel. It's important to understand that it's not only uncertainties for data scientists, but also for business people, because a lot of work that should be done is not just asking researchers about ways to solve it. So, for example, this matrix here, we have, you may know, like both business people and scientists know what to do. So there is no uncertainty at all. It's just a working item. It's just delivery backlog item. And there could be some other situations. For example, scientists don't know something and business people may know. So this is a customer discovery item. So your manager need to go and talk to business people, asking how many, let's say, transactions you would expect. What is how do you make money out of that, and so on. So these are customer discovery items and open questions that manager need to go and ask. I saw a lot of cases where people like they hadn't spent their time on this customer discovery, saying, okay, you know that you already know we need to build a chatbot, let's do that, or we need to build a recommender system, let's do that. There is a lot of kind of a big area of research for business people, not just researchers and scientists. So go ask and get out of the building and do your internal customer, external customer discovery, find out if business people know that and scientists don't. There may be a situation where when data scientists know something and business people don't. For example, they say, I don't know what is, how accurate is, we have recordings in our, like we have voice recordings in our call center. We don't know how many questions are there. For example, how many different requests are there in the system. We don't know that. And the scientists, experienced scientists, they already have that experience, so they make assumptions. They may say, okay, let's assume, for example, how many requests. Well, I've shown you the long tail. I will tell that probably several hundreds or even thousands, but not several dozens. And this is my assumption. When someone comes to me and say, okay, we need a chatbot, okay, so this is going to be a challenging project because we need to create rules for several hundreds of requests. And they say, how do you know that? I know that. I never saw your data, but well, I know that. And this is my assumption. Probably I'm wrong. And yeah, so you keep an eye on those assumptions, but yeah, so put it in a separate list. And there are something that nobody knows, and that data scientists don't know that, and business people don't know that. So this is a really good element of your discovery backlog. And so you take it all and you build a map. Map stands for metrics, assumptions, and plans. And yeah, so on this phase, you need to build a mapping between between money and well, some data science metric like recall or false positive rate or something like that is, or some accuracy. Yeah, this is a good work to do, and for business people, and sometimes you need a consultant to do that. So yeah, we discussed that you need knowledgeable people to work with uncertainties. So please do that. If you cannot disclose dollars, ideally you need to have dollar value. But if you cannot disclose it, use escudo. This is also fine. And that could be some exchange rate, internal exchange rate that is known only by the boss and the manager. They, if scientists say we can save you 10 escudo, you know that one escudo is for $4,500. So you get to your boss, say we can save you $45,000 with that. Yeah, you have your assumptions, and you have a plan, which is a 3D backlog. We'll talk about it later. And of course, you have a map, a kind of a pipeline of your research of your machine learning machine, decision-making machine. And so you put questions, you put uncertainties on that. Probably we know how to do that. It goes to delivery backlog. We don't know how to do that. It goes to discovery backlog. And you have these dragons, and these dragons are critical items that may explode later. So yeah, so you already saw, like Alexei and us had discussed the Mercedes diagram. So what we do, we do pretty much the same thing. We have 3 dimensions and 3D backlog. So we use a standard story mapping approach. You may be familiar with this approach. So we put the releases here, and we put stories for delivery backlog, user stories, and we have algorithms and research items for discovery backlog, and we have data backlog working with data sets. So these are, and it's prioritized. Of course, we need to measure these items and make estimates. Again, you may use, well, story points for that. And as you may imagine, we use escudo. Escudo is a fictional currency. So we understand that escudo is not that accurate, but yeah, one escudo is about 1 man week. And sometimes you may use planning poker or something like that, but sometimes you cannot tell how big is this, because you need to do some research before you know that. And here we put the dragon icon on the sticker. Dragon means, well, it's a sleeping dragon. It may explode because our current estimate is 2 weeks of work, but it may turn out to be 3 months. 3 months, yeah, you don't know that. And so, yeah, put a dragon. It's okay to work with uncertainties in research project. So you have your plans, and yeah, you start exploring. And it brings us to exploration phase, and we have exploration raids for that. Raid is a micro quest. It's typically could be several people working on one particular micro project to find out something, or to obtain a certain loot. So you don't need to go with the hypothesis. Again, I am against of starting with hypothesis. Don't do that. Start with uncertainties. And before you after you identify uncertainties, you need to spend some time looking around, seeing what other people are doing before you make assumptions. Assumptions are pre-hypothesis stage. And you need to with these assumptions, you do some exploration, you have some loot, and this loot could be data sets, that could be some insights, some alternatives, and released code. So you have like insights are available, like it could be notebooks or charts. It could be some exploratory data analysis there, or some some statistical analysis. Alternatives are really good for business cases. You may want to search for research papers, state-of-the-art models. You want to make some market research. You want to evaluate different tools. So these are alternatives, and typically the output is slides and papers that you give to your decision makers. Say, okay, oh, you explored these alternatives. This is good. And the raid is, it could be small, like scouting raid for 1 or 2 people. For example, a senior scientist, a junior researcher seeking for published papers and state-of-art models, or it could be like solo raid with an ML engineer cleansing a raw CSV file. And it could be a massive raid. A massive raid are the most fun of all, because, well, it could be 5, 8 people, or even 15 sometimes. It'd be like a hackathon or a week-long workshop. I took it from our research workshops when I was a scientist. We had 2 professors and several students. We we organized the workshop in some resort, for example, in Egypt, for 4 days, and we had like every day we were researching something and preparing data sets. That was really fun. So we do the same massive rate. So we bring people, knowledgeable people there. It could be like a workshop, a hackathon, and you want to test some interesting assumptions and build a prototype, for example, working prototype, some user interface, sometimes hardware parts. And yeah, so you want to build, to run that experiment in this really intensive way. And yeah, so you need to have different skills there and different schools of magic. This list is not complete, but yeah, so you have people from different areas, and some people come, like analysts coming from School of Drag and Drop Magic with Power BI and Visual Basic and pivot tables. These people are also valuable. So data scientists say, okay, these guys are they are not scientists at all, but they are valuable because they do their Excel work, and they may be really helpful. So don't be too arrogant to other schools of magic. The list is not complete, of course. Yeah. Yeah, but you want to have someone high level, especially when you're stuck in your research. For example, you have a research project that lasts for several months with no outcome. So organize a massive raid, invite high level experts from different schools of magic, and magic will happen. You'll build something really impressive. And this is an example of a massive raid board. It's a mirror board, so you can see some links here. We have mission canvas to help everyone understand what's is expected from this specific rate as a micro quest. We have 3D backlog, which is tracking every day several times. So we have like morning session. When we do it online, we have morning session and evening session with the whole team. And we review the 3D backlog with some development, some research and data. And we have a solution map and we have a loot, like raid loot part where we have retrospective and we measure like hours spent as well here. Scientists don't like report the hours, the working hours. It's annoying, but when it's gamified, we have one Scudo is 1 week, and small currency is Gulden. So Gulden, you need to kind of to say I spent I gained 10 Gulden. That means I spent 10 hours on this. That is really fun. So people like it, and everybody's happy. See how many Guldens or Scudo we gained from this specific rate. Okay, we're approaching the end. I see that we're a little bit stressed without time. Yeah, but yeah, so we get to the crafting session, and after you get some findings, typically raids are targeted. They're good when you have exploration, you have some quick results, and need to get some quick findings. But you need the most systematic way to organize findings and prepare hypotheses and experiments. So this is how we do that. We have the craft formula with understanding problem, solution, and test procedures. So you need to understand who the client is or user in which situation, which is always omitted. People say like who and what, but when. Yeah, when is also really important to know. In which situation? Is it frequent situation? Is it like once a year? Do they have this problem? Do they have it every day? This is really important to know. And well, I saw a lot of kind of trainings on product management. Nobody speaks about situation that deep. That is required. You need to understand how frequent this situation is and learn about the situation, not just user and the problem. Yeah, so the problem and the architecture. So what is solution? Solution is sometimes misunderstood. Solution, in fact, it's a sequence of actions. It's some you start here, you get there. This is solution, and you use some tools there, and you have some features. So describe what are you going to change. You may in your experiment, you may change the architecture, the way you solve the problem. You may change tools. For example, we were using this and we will be using that. Or you may change features, and that could be data science features, or that could be product features. Yeah, so you do experiments changing architectures, tools, and features, and you need to test it. So you need to collect evidence and measure. So these are so test procedures that you need to do. And of course, well, for architects, so this is, let me advertise a little bit resource that we've put online, and we are preparing blueprints of AI solutions, and we are really interested in more knowledgeable solution architects to publish new papers. So these are really, so we see a lot of interest to that resource. It's just started, but we see a lot of interest. We're going to publish 100 solution blueprints for different AI problems, kind of explain what is inside. So yeah, please subscribe. I encourage you to go ahead and check out and subscribe and probably become an author, because we are really interested in great pieces of wisdom for other product managers. And yeah, so you have features, experiments, you need to prioritize them. And yeah, the most advertised way to prioritize features is ICE. So there were several talks about that. I would say no ICE. And I explain you why. So in fact, you compete against existing solutions. That means that you already have some other products in the market, and they have features A, B, C, D, and so on. And some features are well designed according to Kano models. Some of them are must-haves or delighters. Some of them are good enough. Some are quick and dirty. So you need to compete against that. You cannot build a shitty product, put it on the market, and expect that people will be using that and giving you feedback. They will say it's a crap. So yeah, so there are different ways to prioritize your experiments and features. The first one is ice and rice. In fact, it says that let's pick the most valuable features and the easiest and most valuable. Yeah, this is great, guys, but that is great for a mature product when you have like already other features that are must-haves, and you invest in some specific features to build it better than competition. But there may be other, like you have a really great recommender system, but there is no login screen because, well, login screen is not that valuable. And well, let's focus on our recommender system. Well, it looks like no, but when I see real prioritization, this is the case. And there is another way. It's called working skeleton. It says, okay, you need to implement all features, all must-have features first, at least at the quick and dirty level, but you need the complete experience for your clients. So you don't invest in valuable, you don't invest in easy, but you need to kind of to fill all the check boxes. And there is a like third way, which is called RAT or RAT, which is a riskiest assumption test. When you select features not based on their value, not based on their ease, but based on is it risky? So this idea, this concept, is it risky or not? So these are three ideas, and so what we have, it's called zero to hero prioritization, which we find the best as a combination of several ideas. And you need to have a killer feature. You need to have at least one feature which is a purchase reason to other clients to buy or try this product. You need to have something that is way better than competition. And you need to find out which this feature is, why people pay for that, why they're gonna pay. And this is gonna be your state-of-the-art feature that you need to build, like it should be mind-blowing. The rest, the other features, you implement them at quick and dirty level, following the walking skeleton approach, and you need to have several RATs, several features to test your riskiest assumptions. So this is the best way, the most kind of lean way that we see. And yeah, I encourage every time when I manage the product, I kind of work with sites. We want to improve that. I said, stop. We need to first to build that must-have feature, which is part of our working skeleton solution. You will kind of improve your accuracy of the model later, but first we need to build a classifier on pre-processing part of the pipeline. Okay, so yeah, so use that, and finally we get to the testing phase, and we need to go through the labyrinth with our lab and our team. And yeah, so we use Kanban canvas here. So it's between the discovery backlog and delivery backlog. In fact, what do you do during your discovery phase? You build some prototypes, some experiments, some pieces of code that will be incorporated into delivery backlog. They will be part of a software solution. And so don't change the way that developers are working. So they will be working with a standard Scrum, Kanban, or something else. So delivery process will be established, and discovery process needs to kind of to create assets to those delivery people. And so we have so these the first phase is assumptions phase, when we do some rates and some exploration. Then we get to hypothesis. We prepare experiments. That could take some preparation, and we run experiments that may take time. For example, if the model is training for 1 week, sometimes deep learning models may take several weeks to train. So you have experiments, and then you create artifacts. You need to, once you have the results, you need to either kind of put them into museum, which is a database of your results. Please spend your time on organizing your assets and organizing your research, like papers or reports, or it could come to your GitHub and to the delivery part. You need to prepare to create artifacts that could be given to the software team. Yeah, and well, even if your lean approach is very good organized, you still have uncertainties and you still have dragons. And dragons are reasons why AI project gets stuck. Well, so for example, you have a research item. And this research item is some uncertainty. There is some uncertainty inside, and you say, I can solve it within 2 weeks. So use this checklist. If there is some signal that there is a dragon here, put a dragon icon on that. So all work items, depending on senior level decisions, they may explode. They may be like, they will decide something crazy. They decide to use different vendor. They decide to test it on a different factory. They decide something that you may not predict. And well, if it depends on a senior level decision, put a dragon icon on this sticker. So if there is real-time processing, put a dragon icon. If there is data restrictions, data access restrictions that could take weeks to get through to get access to data, yeah. Well, if it depends on assessors or human developer operators, if it's dependent on untransparent third-party tools, put a dragon icon on that. And finally, if you do some statistical analysis, you find out that you have sparse data, you have scarce data, and you have long tail distributions, put a dragon icon on that. You don't know how long it's going to take. It may take forever. Okay, so let me make it clear again. We have a labyrinth. We have a potential. You need to make decisions early in the project, and some decisions may lead you in the wrong direction. You'll spend a lot of time, and you need to kind of take these risks and identify dragons as early as possible. That's why you need rats. So use rats against dragons. Put the rat on this path and make it really quick to go to the dead end to find out there's a dead end there. So that's why you need rats. And yeah, so this is clear for everyone, but when they look from like third-party observer, we'll see something like that. They will see that you started well, then you had some progress, then you, for some reason, you get to the client, or that you have a demo day and they say, wow, your accuracy dropped. Why was that? That's because of like data mismatch. For example, they bring you new data and the system wasn't trained on the data, or they are trying new algorithm. There's like, they need to get back, as we saw in the labyrinth, they need to get back and start over. And well, this is crazy for sponsors. They say, well, this data science team is incompetent. Probably we need to stop it, to hard stop it. Yeah, so this is really, that happens really frequently. And as a data science manager or data AI manager, you need to know about that. You need to kind of, again, you may have some dirty tricks. For example, you may use overfitting. For example, you may ask your team to kind of to beat the score with this data available. Yeah, but it's not a good idea at all, because you'll have problems down the road with, once you deploy your system and well, on with real data feed, it will show you really bad results. And to having a robust model is much better than having accurate model. And it's hard to explain to business people, but well, it's your job as data science manager. You need to explain that 80% accuracy or 85% accuracy is good for that type of problems, because well, other state of art models, they show like 70% or 75%. So if we fine tune it that well, probably it's already a breakthrough. Okay, so you did all that, so you're doing fine, and you have your final encounter with the boss. Why do you need to do that? It's to get a new sponsorship, right? You need to go through that and show the results and show that your decision-making machine is great. It works really great. So the problem is solved. Probably it's not 95% accuracy yet, but you need to convince the boss, and you need to talk the same language as the boss to kind of to convince him or her to continue and get to the next phase. And so this is a template of your slides. You need kind of to show him or her, you need to show your quest giver that you understand the business need and the investment. You really appreciate the investment. And you need, well, he or she wants to be entertained. Yeah, because, well, they're paying. They want to have some fun. Yeah, they need to be entertained and inspired. So they want to see alternatives. That's not we took this way and we will go forward with this way. No, you need to show there are several alternatives and we tried this and that and we feel this is better. This is our solution. And yeah, so invest in UI, and sometimes scientists bring an ugly, indigestible report and spend some time to prepare it more stunning visuals. And explain what you want to do next. And what was your like a Scudo estimation for the next phase and the Scudo estimation of the outcome. So yeah, complete quest and accept a new quest.